Welcome, my dear students, to the channel Iconic Maths Srihari. This video is on modulus inequalities, which gives information about various results, and they are very much useful for exams like RMO, INMO, IITZ, BITSAT, and many other competitive exams. Now, let us start. About this modulus inequalities, this is a different concept of higher importance in higher mathematics. Modulus inequalities, which involves modulus function and inequalities in including modulus. Those are called as modulus inequalities. First of all, we should know what you mean by a modulus function. A modulus function. See, a modulus function is a function which is defined as mod x is equal to x if x is positive, and minus x if x is less than 0, and 0 if x is equal to 0. See, my dear students, the modulus function is defined as this symbol, two parallel lines. Between that x is there. That is defined as same x if x is positive number, and minus x if x is less than 0, and 0 if x is equal to 0. Right? Let us understand by some examples of this function, and we will further do problems on these modulus inequalities, my dear students. For example, you take here modulus of 5. This is equal to 5 because 5 is greater than 0. That's why we took 5. X is 5, that is positive. That's why mod x is equal to x we have got. Now, second one, modulus of minus 5. Right? And here minus 5 is less than 0, my dear students. That's why if it is less than 0, here x is equal to minus 5. Right? Once x is equal to minus 5, here we take, okay, x is equal to here minus 5. If it is negative, x less than 0, here minus 5 is less than 0, that's why you need to take minus of x, that is minus of minus 5. That means you got it as plus 5, right? You got this as plus 5. That means if you give input value, negative values also to this modulus function inside, it will come out as a positive value. That's why this modulus function is called as a positive function, my dear students. And modulus of 0 is equal to 0. Okay, fine. Number 4, modulus of minus 7 is equal to 7 only, because this is nothing but minus of minus 7, because it is minus x and x is what here? Minus 7. That's why modulus of x is equal to minus x if x is negative. Therefore, whatever value you give inside of this modulus function, it gives as what it will gives you is output as a positive value, right? That's what you observe. Now, therefore, my dear students, modulus of x precisely we can define it as plus or minus x, like this. That means what are the input values you can give to modulus of x means plus x you may give or minus x you may give, but the outcome value we are going to get plus x if x is positive and minus x if x is negative. And 0 means it is plus or minus of 0, that becomes 0. Right? Therefore, modulus of x is defined, my dear students, is equal to plus or minus x, when x is any real number, when x belongs to real number. This is what precisely our modulus function definition. Now, we are having some inequalities in this. The first result under this is modulus of x is less than a. Modulus of x is less than a, that implies okay, minus a less than x less than a. How we are getting this? Now let us get this right in this video. Okay, the proof for our solution, how we are going to prove is modulus of x means, now only we discussed, this is plus or minus x. That means, my dear students, here plus or minus x is less than a. That means x is less than a. Okay, and another one is right, you have minus x is less than a, like this. Right, that means x is less than a, and minus x less than a means if you multiply minus on both sides to minus x less than a, then you will get x is greater than minus a, because this you got by multiplying minus sign on both sides, you will be getting this. Now let us club this, my dear students. X is greater than minus a means, so you know that minus a is less than x, right? And x is already less than a, that's why we have got like this. Therefore, whenever modulus of x is less than a, we have got this minus a less than x less than a. And the real number line, in real number line we can show that it as minus infinity we are having here, and plus infinity if we have here, this is minus a and this is plus a means okay, here I am opening a circle. Okay, it is not filled up, and this is what now you observe this shaded portion minus a to a in the real number line will give us the solution set in this. Okay, and also, my dear students, we can say that x belongs to minus a comma a, like this. We can even say in the form of intervals like this. Therefore, once again, if we have modulus of x is defined as plus or minus x by the definition when x belongs to R. When x is positive, it is plus x, and x is negative, it becomes minus x. We already discussed it. Now, modulus of x is less than a means minus a less than x less than a. Right? How we have got is modulus of x is equal to plus or minus x. Now, plus or minus x is less than a means one is x less than a and another one is minus x is less than a. We are having like this. Now, x is less than a, and multiply minus sign for minus x less than a, you get x greater than minus a. Now, clubbing these two together, minus a less than x less than a. That we can show in the real number line like this, minus infinity to plus infinity, minus a and a. Between that portion is our now required answer, right? Now, the second result, my dear students, mod x is lesser than or equal to a. Already by the previous result, we have mod x is less than a, here lesser than or equal to. By that, we will get minus a lesser than or equal to x lesser than or equal to a. Right, by the previous result that we have shown in the real number line. Here equal to means this circle is shaded, that means that is included. Here also this circle is shaded, okay, that is included. Minus a and a is included, and between those values will be, that means x belongs to minus a to a, which is our closed interval minus a to a. That means minus a and a are included, and all the real numbers between minus a and a are there, right? Now, the third result, modulus of x is greater than a. That means modulus of x means, we know that already, modulus of x means plus or minus x when x belongs to R. Right? plus or minus x is greater than a. That means x is greater than a and minus x is greater than a. We have got this, right? X is greater than a and minus x is greater than a. Now minus x is greater than a means you multiplying by minus sign on both sides. We will get here by multiplying minus sign on both sides. This is x and this inequality we know that it will be reversed. X less than minus a. Okay, and another one we have got x is greater than a. X is greater than a. Now we have got one is x is greater than a and x is less than minus a. Those are what the required solutions. Minus infinity to minus a and a to plus infinity we are having here. Therefore x belongs to minus infinity to minus a union a to plus infinity. This is what the solution set when modulus of x is greater than a. Now the fourth result, modulus of x is greater than or equal to a. Already by a previous result, modulus of x is greater than a. Now we replace it by greater than or equal to. We have x lesser than or equal to minus a and x greater than or equal to a. That means on the real number line minus infinity to minus, okay, plus infinity, minus a will be here and plus a is here. Okay, x lesser than or equal to minus a means this part we have, and x greater than or equal to a means that part. Okay, and the circles are shaded, completed like that. That means they are included there like this. Therefore x belongs to in the interval form. We are going to have minus infinity comma minus a union a to plus infinity. And also my dear students, this both solutions combinedly we can write it as, right, x lesser than or equal to minus a means minus a greater than or equal to x we can write, and x is greater than or equal to a, like this we can write combinedly. X lesser than or equal to minus a we can write it as minus a greater than or equal to x and x is greater than or equal to a. Combinedly like this also we can write. Now some problems based on what we have discussed the results. First one, solve modulus of x less than 5, and second one, modulus of x lesser than or equal to 5. Third one, modulus of x greater than 5 and modulus of x greater than or equal to 5. The solution part, modulus of x less than 5 means by our result modulus of x less than a means minus a less than x less than a. Now minus 5 and plus 5 on the real number line we have shown, and between that and minus 5 is not included and 5 is not included. That's why the circle is not shaded there. Therefore x belongs to minus 5 to 5. Like this we can do this particular problem. Now the second one, they have included modulus of x lesser than or equal to 5. That means you have here now minus 5 lesser than or equal to x lesser than or equal to 5 you are having like this. That means this real number line you are having here minus infinity to plus infinity, right? Here you have, right, minus 5 and here plus 5. Here these circles both are now shaded. That means they are included here, and this part, shaded part, both will be included. Therefore here now x belongs to minus 5 comma 5 like this, minus 5 comma 5. This is what now closed interval minus 5 comma 5. For the first interval, first problem, x belongs to minus 5 comma 5 open interval. I think you got the difference between both of them. Now the third problem, modulus of x is greater than 5. If modulus of x is greater than a, we discussed that x is less than minus a and x is greater than, okay, x is greater than 5. Now this is, we have in the place of a 5 we are having here. X is less than minus 5 means we have represented this on real number line like this. This is what minus 5 and this is plus 5. And here the circle is open because it is not included. Here also the circle is open, that is not included. That's why now minus infinity to minus 5 and 5 to infinity, because x less than minus 5 means this part and x greater than 5 means this part. Therefore x belongs to minus infinity to minus 5 union 5 to infinity. This is the solution set for the third problem. Now the fourth one, you can understand easily. Modulus of x is greater than or equal to 5 means we are going to include 5. Therefore, you are having this as, that means x is lesser than or equal to -5 and x is greater than or equal to +5. This, right? Now this how we are going to represent on the real number line is, this is -5 and this is +5. Here this circle part is shaded and you have like this. Here this circle part is shaded and you have like this, and this total shaded portion you are having like this. This total shaded portion. From this, therefore, my dear students, x belongs to, you will have -infinity comma -5. That is included here, union, and this is now 5 to infinity, like this. 5 to infinity. This is what the solution set for the fourth problem. Now, students, we have the next set of results which are based on the first 4 modulus inequalities results. Now, what are those results means? Here R and A we are going to use 2 constants. R be a positive real number R, and A be any fixed real number like this. R is any positive real number and A be any fixed real number. Then we have the first result, modulus of x minus A less than R means A minus R less than x less than A plus R. That means x values will lie between A minus R and A plus R. That is what x belongs to open interval A minus R comma A plus R. Okay, these are the results. We are going to prove them like that, right? Now the second one, we have modulus of x minus A lesser than or equal to R. Only the difference from first one and second one is here less than and here lesser than or equal to R. That means we have, right, A minus R lesser than or equal to x lesser than or equal to A plus R, like this. That means x belongs to closed interval A minus R comma A plus R we are having like this, right? Okay, now the third one, we have the third one, modulus of x minus A greater than R. You can expect that, right? Greater than R. That means x is less than A minus R or x is greater than A plus R here. X is greater than A plus R here. You are going to have x is greater than A plus R like this, right? Now the fourth result, when modulus of x minus A greater than or equal to R, now we are having equal symbol for the third one. The same result we are going to get, but including the R, like including symbol, like equal symbol. That means x lesser than or equal to A minus R and x greater than or equal to A plus R we are going to get like this. Right? This is what x lesser than or equal to A minus R and x greater than or equal to A plus R. These are the results we have got. Now we will be discussing the proof of them also. Please observe. Now the proof part of the first result, modulus of x minus A less than R. My dear students, it is very simple. We can do it. Let us take for understanding purpose x minus A equal to y. Now modulus of y is less than R. Now from the previous result, first result, we know that minus R less than y less than R. Okay. Now you replace y by x minus A. Minus R less than x minus A less than R. Right. Now we need x value. Adding A on both sides, we get that, okay, A minus R less than x minus A plus A and A plus R we are having. Now A minus R less than x less than A plus R, because minus A and plus A will cancel. That means x belongs to open interval A minus R comma A plus R, like this. Like this we will get this first proof. Now the second proof, we were going to get the second proof. We are having just lesser than or equal to symbol. Now everything you replace by equal symbol. Now here also equal symbol, here also equal symbol, here also equal symbol, here also equal symbol. Same, now adding a on both sides, we are going to have this lesser than or equal to, lesser than or equal to. Here also lesser than or equal to, lesser than or equal to. Now this open interval becomes, now everything lesser than or equal to, that means x belongs to, now this open interval become closed interval. Now we have got closed interval. Like this, we have got the solution set for the second result. Now the third result, modulus of x minus a greater than r. Now as usual, for our understanding purpose, let us take x minus a as y. That means our problem result reduces to modulus of y greater than r. Now we know from the previous result, whenever modulus of y greater than r means y less than minus r, or y greater than r. Because we know modulus of x greater than a means x less than minus a or x greater than a. Now you replace y by x minus a. X minus a less than minus r, or x minus a greater than r. Now x minus a less than minus r means by adding a on both sides, you will get x less than a minus r. Otherwise you will transfer this minus a to that side, then it becomes plus a. X less than a minus r, or x minus a greater than r means x is greater than a plus r. Therefore x belongs to minus infinity comma a minus r union a plus r to infinity is what the solution set which tells about this equation. Like this, we are having the solution set for the third one. Now the fourth one, what we have is the fourth one, modulus of x minus a greater than or equal to r. Now everything we replace by equal. Here also equal symbol, here also equal symbol, here also equal, here also equal, here also equal, here also equal. Now this minus infinity is open only because it is never included, and this become closed, like, and this finite value become closed, and remaining thing become infinity, become open interval, because its value is not known and it is not included. That's why. Okay, like this, these four results we can prove, my dear students. Now based on these, we will do certain problems. Now let us solve one problem, my dear students. Solve modulus of 3x minus 2 less than 1 by 2. This is the problem. How we will do? We know that now only we proved one result. Modulus of x minus a less than r means a minus r less than x less than a plus r. Now in the place of x we are having now 3x. In the place of a you are having 2 and r 1 by 2. That's why now 2 minus 1 by 2 less than 3x less than 2 plus 1 by 2. 2 minus 1 by 2 become 3 by 2 less than 3x less than 2 plus 1 by 2 become 5 by 2. We need only x values. You divide throughout by 3. Then it become 3 by 2 by 3 become 3 cancel 1 by 2 less than x. This become 3x by 3 becomes x less than 5 by 2 by 3, that become 5 by 6. Therefore x belongs to 1 by 2 open interval 1 by 2 comma 5 by 6 is what our solution. Now the same problem, second problem with equal symbol lesser than or equal to. If we do this, my dear students, here also we will have equal symbol, here also we will have equal symbol, like this. The result will be, now the same thing will be now with equal symbols. We are going to have here also equal symbol we are going to have, here also we are going to same procedure, equal symbols. Now this open intervals becomes closed intervals. These open interval, because now these are included, that's why these open intervals will become now closed intervals. Like this, this problem when we have included these, okay, when we included equal symbol is there, this is what the solution set we are going to get. Now the third problem, solve modulus of 3x minus 2 greater than 1 by 2. Same problem with we are changing the unequal symbols. Then you will understand clearly. Okay. Now we are going to use the result modulus of x minus a greater than r. That means x less than a minus r or x greater than a plus r. Right. Here x place you have 3x and a place 2, r is 1 by 2. That means 3x less than 2 minus 1 by 2 by this. or 3x is greater than 2 plus 1 by 2, because x means here 3x and a is 2, 1, r is 1 by 2. 3x less than 2 minus 1 by 2 is 3 by 2, or 3x is greater than 5 by 2. That implies 3 cancels here, x less than 1 by 2, or x is greater than 5 by 2 into 1 by 3, that is 5 by 6 you are going to get. Therefore, x belongs to minus infinity comma 1 by 2 open intervals union 5 by 6 comma plus infinity. That we can represent on the real number line also, minus infinity to plus infinity. Here 1 by 2 you are having, 5 by 6 is you are having. X less than 1 by 2 means this part, x greater than 5 by 6 means that part. Like this, my dear students, we can solve these problems. Now the third problem like this. Now, okay, one more problem what we are going to include. Now we are going to include greater than or equal to. Now we are covering all set of problems, right? All set of problems. When we have, then we are going to use this result when they are included, like equal symbols we are going to use. Now here also lesser than or equal to, here also greater than or equal to, here lesser than or equal to, here greater than or equal to, here lesser than or equal to, here greater than or equal to you will have, and this result instead of here open interval you are going to have a closed interval like this, and here 1 by 2 is included and 5 by 6 is included. Instead of this open circle here, now it is filled up. Now it is filled up like this. This is what the solution set. In this video, my dear students, we have discussed totally 8 results and the problems which are based on them. These are very highly important in this model, and please subscribe to the channel. New videos you will be getting time to time. Thank you. Thank you very much.
Thank you very much.